Hey everybody, welcome to video number 11. This is actually recorded in 2016, so it's fresh and up to date for you. And in this video I'm going to show you how to import AVIRIS hyperspectral data into ArcMap. So what is AVIRIS data? It's hyperspectral data. It has 224 bands. It's collected on a NASA airplane, usually in pretty limited strips, so limited spatial extent as opposed to satellite data. But of course, the advantage of hyperspectral imagery is we should be able to resolve a lot of spectral features that we wouldn't otherwise be able to see. So in this video, we'll quickly go through where you can find AVIRIS data. Then we'll talk about the metadata. Then I'll show you how to make a header file for a .bip format. This is the format that the AVIRIS data comes in, and Arc isn't great at importing it. So we'll have to make our own header file. And then once we get it into Arc, I'll show you how to clip it and export it to a TIFF format using the image analysis window in ArcMap. Okay, so here we go. First thing, where can we get AVIRIS data? Of course, I went and searched in Google, AVIRIS download, came up with a number of good hits. Many of them are from the AVIRIS website, which is hosted at JPL. And I picked the AVIRIS locator tool, which brings me to this page. And I can click through here. Well, actually, I guess I'm already on the locator page, so that's great. You can get instructions here if you're curious. But what I did is I downloaded an image for this tutorial from the Gulf of Mexico in the summer of 2010. And the goal of this tutorial is going to be to see if we can use the hyperspectral data to look at an oil spill that happened associated with the Deepwater Horizon drilling rig in 2010. And you might remember the wellhead blew out and gushed oil for a couple of months, creating some pretty nasty oil slicks. So I went in and I picked an image here in the Gulf, and they were flying a lot of missions at this time to try to monitor this oil spill and figure out how to clean it up. So I downloaded that for you. And I'll just note that anytime the AVIRIS data will arrive as both a zipped and tarred file. So it's been compressed twice, which means you're going to have to uncompress it twice. So here's the file you would download, tar.gz. In my computer, I can right-click and use 7-zip to extract the files. Then I end up with a tar file, and so I'd have to actually right-click and extract it again. And then I end up with this folder. Okay, this folder has all the AVIRIS files in it. For today's lab, I've already put this folder into our course folder on the Splinter server. So you need to make your way to the GAL222 folder on the Splinter courses. And under Lab 3 and under Tutorial, you'll find the folder that I've unpacked for you. And if you open that, you'll see a whole bunch of different files. Wow, that's pretty intimidating. Almost all of these files are what we'd call metadata. They contain important information on how the image was collected and information you need to know to interpret and use the image. So we're not going to use a lot of these. A lot of these aren't important for what we're doing today. But if you want to know kind of what each file is, you'd start with the README file here and open that up. And that's going to basically give us a quick rundown on a bunch of info, including here's a list of all the metadata files that should be in the folder. And then it goes on to basically tell you what each of those files should be about. And a couple of the important ones, well, I'm going to skip all of them except to say the one we're looking for now is the image header file. So it's this one. Excuse me, actually, we're looking for this one, the ortho-corrected scaled radiance image file. So this is the image we'll be using, and this is its header right here. So we're looking for the ort_img extension. So we look here on our list, and sure enough, here it is, the ortho rectified image. And if we zoom out here, we can see that sure enough, this orthorectified image is 4.4 gigabytes. It's humongous. And it is obviously the main file that has most of the data we're going to want to use. Now with the same root name right here, but the .hdr extension is the header file. So this contains information about this. And by the way, in the folder you'll be looking at, this .bip extension will not be there yet. So, okay, so let's open the header. To do that, I'm going to just add a .text extension to it. That's going to let my computer recognize what it is. And I'll right-click it and open it with Notepad. You can open it with any text editor. And right away you can see in this header file is meant for Envy. It's not meant for ArcMap. And there's no ArcMap header included with this AVIRIS data. And so we're going to take the data in this header file and we're going to make a new header for ArcMap. So what data are in here? Well, we've got the pixel size, 12.1 meters. We've got the datum, WGS84, the projection, which is UTM, zone 16 north. Then we've got the coordinates of the center of the upper left pixel. So that would be the longitude of it in meters UTM. That's the latitude of it in meters. We've got the number of columns, which Envy likes to call samples. And then we've got the number of rows in the image, which Envy likes to call lines. The number of spectral bands, 224. And then we've importantly got here the file type. And it's a band interleaved by pixel, so a BIP file. That's a type of binary file. And then if you keep going down, there's a bunch of different wavelengths, and so these are the center wavelengths for each band in order. So this is the wavelength of band 1, band 2, band 3, and so on. Notice that by the time you get to band 10, we're maybe roughly in the blue. By the time we get out to band 20, maybe we're roughly in the green. By the time we're out to band 30, maybe we're roughly in the red wavelengths. So those first kind of 30 or 40 bands are basically in the visible spectrum. Okay, so now we got to make our own header file. Now to do that, I'm going to just open up a new document in Notepad. Okay, so it's a blank document. And now I'm going to fill it in with the information that we need. But before I do that, I want to quickly show you where I got some information about making a header file. And that was from a couple documents I found online. One was from McGill University, and that's in the class folder. Really helpful. Another document I found in the ArcMap help, which talks about how to make header files for binary rasters. And those are both available to you, or you could look them up online. So using those helpful documents, I was able to figure out what information to put into the header file. And the way these files work for ArcMap is there's always a keyword, in this case number of rows or n rows, followed by a value, in this case the number of rows in the image. If a line doesn't start with one of those keywords, it just ignores it. So we can put in a couple lines up top that are just comments to ourselves or whatever, and it will ignore them unless they start with a keyword. So we got number of rows, number of columns, number of spectral bands, number of bits, so it's 16-bit data. The layout of the file is band interleaved by pixel. Don't skip any bytes in the header. This is the byte order. I had to experiment a bit with that. Here's the coordinates of the upper left pixel and the pixel size. So there's the key info we'd need in a header. Notice we don't have any projection information in this, and we're going to add that later to the file. So what I'm going to do is I'm going to go and save this now into the same folder that the image is in. And so I'll navigate back to the course folder. And importantly, I'm going to have to save this with the same root name as the image itself. So here's that ortho-rectified image root name. So I'm going to save it as that root name. Then I'm going to add the .hdr extension. And I'm not going to put the .text extension on. And that way it's going to know that it's a .header file. That header is going to be the extension. So I've saved that. Let's go check and make sure that it is indeed there. Yep, so here's the one I just made. Now this header file was the old env one. So to avoid confusing myself, I'm going to add in the word env here so that I know that's the env header that I won't be using. And of course, if I wanted to use it in env at some point, I'd have to get rid of both the env and the text extensions, so it had a .hdr extension. Okay, so now we've got the Arc header file. The last thing we need to do is actually add an extension to this image, and we're going to add a .bip extension. And that's going to let Arc recognize that as a band interleaved file, recognize it as a raster that it can potentially import. All right, so now we'll go to Arc and try to add this file. I've just got a blank project here, and I'm going to go to Add Data and try to add in this BIP image. Luckily, it did see it. That's great. Knows what it is. So now I'm going to click Add, and it's going to take a while. So I'm going to go ahead and not build pyramids. And here it's telling me that it doesn't know the spatial reference, because in that header file there was no coordinate system or projection information. That's okay, we're going to add that a little bit later. So I'll just hit OK. Now I'll pause the video as it tries to load and draw this. This is going to take a while. Okay, so after a few minutes, Arc stopped drawing, the spinning globe went away, and we see the full AVIRIS strip. So this is shaped like a strip because the plane was flying south to north, collecting that data in a single strip. So obviously we can't see anything yet, it's black. That's because either the band selection is no good or the contrast stretch is not appropriate. So I'm going to do a couple things here. First, I'm just going to try to zoom in a couple shots. So I'm only looking at the middle part of the image. Okay, that seemed to work okay. Now I'm going to do some new band assignments. And remember that the red band was roughly band 30, and the green wavelength was roughly band 20, and the blue wavelength was roughly band 10. So I'm going to choose those as approximate true color assignments. And then importantly, I'm going to have it draw statistics not from each individual raster, but from the current display extent. That's really important for getting this contrast stretch correct. And then why don't we try a histogram equalize contrast stretch. Now importantly, it's probably going to ask me if I want to make statistics, and it will say yes if it does. Okay, it didn't. So let's pause while it tries to draw this here. Okay, so it took a minute, but it did draw it, and it looks good. We're seeing the colors and the patterns that we expect, which means the file was imported correctly. And most of what we're seeing down here is cloud interference. But if we look up here, we got a little bit of a cloud-free window. So I'm going to zoom in right in here, that center part of the image, and we can actually see a pretty nice oil slick there. So this brown stuff is the really dense oil, and then this lighter stuff is kind of medium thickness oil, and then presumably this darker blue is no oil at all. So the next thing to do is now to clip this image. This is a huge 4.4 gigabyte image. For this tutorial, we only want to work with a much smaller piece of it. So I showed you previously how to use the raster clip tool in Arc Toolbox to do a clip. There's another way to do it, which is maybe a little faster, and that's in this image analysis window. And this window is kind of like, well, what it is, it's a little module within Arc that's intended to facilitate working with multispectral satellite imagery in easier, faster ways. So in some ways, it's almost a little mini Envy built into Arc, and it's really intended for manipulating imagery. So it has a built-in clip function, which is pretty cool. So I'm going to first highlight the file name, and then you're going to see all these buttons come alive. And this button here is the clip, and what it does is it just clips the image to your view extent. So I'm actually going to change my view extent slightly before I clip. I think I'm going to kind of zoom in. Yeah, I like that a little bit better. Maybe I'll even zoom in a little more. So zoom in something like that. Okay, then I'm going to hit the clip button, and it's very fast. It's produced a temporary raster here that's been clipped. Now, really importantly, that's just temporary. So it's not saved in your folder anywhere useful yet. So to make it into a permanent raster, we're going to now export this data. So to do that, we can right-click on the layer, go to Data, and then Export Data. And this will bring up a window with a bunch of options, and take some time and look over these. But most of the defaults are pretty good. We're gonna output the whole raster data set. We're going to use the spatial reference of the existing data set. It actually doesn't have any, so that's no problem. Here it's giving us the cell size. And then importantly, make sure you're saving this in a file path to your own folder. You don't want to be saving this to the class folder. You want to be saving it into your GG students folder, okay, under Lab 3. Then of course we got to name it here, and I'll name it oil spill underscore clip. I'm going to export it in a GeoTIFF format. So importantly, it's now, as it exports it, it's going to convert it from the BIP format into the GeoTIFF format. And that's going to be a little bit easier for us to work with going forward. All right, so I'm going to hit save now. All these things look good. And looks like I've already actually done this, so it's going to ask me if I want to overwrite it. I guess I won't bother to. You should save it. In my experience, it has crashed Arc when I try this. Might not crash yours, but if it does, what you want to do is wait for the progress bar to finish exporting the file and then restart Arc. So I'll pause now while you try to export this, and you should create a new TIFF file. Okay, so my Arc did crash during the export of that clipped TIFF. Not sure if yours did. Regardless, I'd like for us all now to start with a fresh ArcMap project. So either close Arc and restart it, or go to File, New, and get yourself into a brand new, fresh Arc project. And then the first thing we're going to do now is actually go into Arc Catalog, and we're going to find that clipped image that we just made, which in my case is in here. In your case, it'll be in your GG students. So here it is, oil spill clip. And what we're going to do now is add spatial reference information. So to do that, we can right-click and go to Properties. And here's a bunch of information. We'll scroll down until you get to Spatial Reference and click Edit. Now we know from the header data we looked at that it is in a projected UTM zone 16 north projection. We haven't talked about projections in this class yet, so don't worry, we'll get to them eventually. But for now, the way we would find this is we'll look under projected coordinate systems. Then we'll look under UTM. WGS84 was the coordinate system. We know that the Gulf of Mexico is in the northern hemisphere, and so we're now going to find UTM zone 16N, okay? So that's the coordinate system and the projection. And we'll hit OK. It's now going to add this information in, probably make a new header file, or just add it into the file info. And we'll hit OK. So importantly now, Arc is going to be able to know where this image is located. So let's go ahead and add it by dragging and dropping it into our table of contents. We'll close Arc Catalog because we don't need it anymore. And we'll wait a second for this to draw. Now we've lost our display information, so I'm quickly going to go back in and add that. Recall red is band 30, green is band 20, blue is roughly band 10. Whoops, missed that. Okay, and again we're going to take the statistics from the current display extent and we'll try a histogram equalize stretch. So we've specified the band assignments to true color, specified the contrast stretch, hit OK, wait for it to draw. Great, so here's the image rendered in roughly true color. It's clipped and it's now in GeoTIFF format. So basically we are now in ArcMap and ready to go. Last thing we'll do is just save this. Again, make sure you're saving this to your GG Students folder. Give it a name that makes sense, like Lab 3 AVIRIS, and hit save. And join me for the next video in which I'll show you how to convert this AVIRIS data into radians using the image analysis window in ArcMap. Thanks.